Hello, my name is Jason Bard, and I am a senior undergraduate in mathematics.
Hello, my name is Sambar Bral. I'm a junior undergrad in computer science. Today we're explaining our research project in mimicking Hendrik Karpathy 100 lines of RNN code using NumPy published in GitHub in 2015. The Python code is replicated using an open source machine learning framework called PyTorch. It leverages the capacity to create a powerful and flexible recurrent neural network model by using GPU performance in this study because we can experiment with different cost activation function learning and training protocols and other improvements. In general, vanilla recurrent neural network is a step function that produces a sequence of vectors with a hidden state that gives every step updated when it's called. It's a very powerful model because it helps design RNN architecture. Therefore, in our study, the character level RNN language model architecture is used, which allows it to find patterns to predict using directed graphs. So the PyTorch model is trained on text data as an input vector using one of k encoding for each character that predicts what the text will be next.
So in 2015, Karpathy published an article titled The Unreasonable Effectiveness of Recurrent Neural Networks, and his code he used to do it used NumPy, which is another package framework of Python. And it's good at handling matrices and lists in the form of arrays. However, PyTorch instead uses tensors, which are much more flexible at influencing these lists element-wise. This means we can easily handle our one of k lists and assign them to characters in the text file. So all in all, we're trying to emulate Karpathy's code in a new and easier format.
So we basically have a giant string of characters that we plugged into RNN one at a time. Then we train them to RNN. Then we use RNN to generate sample sequence that it is seen in its training data. It starts to recognize patterns on the text file, differentiate word punctuation when training more and more. It takes input of sequence of characters vectors that the model tries to predict the next character in sequence. Since it takes input vectors, we need one of k encoding every time into the RNN, which updates the hidden state based on Karpathy recurrent formula. In every time it steps using gradient descent to backpropagate through the network to find and adjust the gradient weight so that the predictions are more consistent using three layers, hidden, input, and output. We have 512 hidden nodes for each layer. In the figure, we can see that the one of k vectors are being used, also known as hot data, on character H, which uses 100 that represent in the red box that weight the vector w underscore xh, which goes to the input layer to the hidden layer represented by the green box. Inside the hidden layer, most of the processing happen while updating the recurring formula. And at the end of the output, we can see the H is predicting the letter E with 2.2, which is labeled as green, which should always be high, and other 1, -3, and 4.1 as a red, which should be always low. This is how it can backpropagate to the output and predict the next character E. Now we can increase this thing into a big data, and we can always predict the next character in sequence.
So in order to make this work, we need a form of cross-entropy, which is a method to turn our list into a probability distribution, which is compared against the one of k encoding in order to see what character is most likely to come next. In addition, we also need a softmax function, which is in the figure in the black box, which turns this probability distribution given by the cross-entropy algorithm into a scaled vector such that the entire thing sums to 1. This normalizes the probabilities and makes it easier for PyTorch to handle. I'd like to thank Dr. Pedro Maya and Dr. Dokgun Park for assistance in this and our future research. And also I'd like to thank Nathalie Fernando and Hassan Mazharul Islam for their assistance as well. For more information, we've left our emails on the poster below.
And also, we have left the link in the poster, so you can go look at the Hendrik Karpathy code and do something creative. Thank you.